Good afternoon and welcome to this week's IGC Events webinar Focus on Geothermal, which is presented by FIG Geoenergy and Enerchange. My name is Jochen Schneider and today I'm pleased to welcome Albert Genter, Deputy General Manager of ÉS Geothermie, who will provide new insights on the geothermal development in Alsace. Albert Genter is geologist and was working for many years at the BRGM, the French Geological Survey, as Deputy Manager of the Geothermal Division. In 2007, he became Scientific Director in Soultz-sous-Forêts, and since 2014, he is working at ÉS in Strasbourg. Actually, Albert Genter's team is operating two geothermal plants producing electricity in Soultz-sous-Forêts and heat in Rittershofen, and they are developing further plants in Alsace. He's currently also board member of the French Geothermal Association. With today's presentation, Albert will talk about the history of the geothermal development in Alsace, as well as the encountered social issues and how they were addressed. We are looking forward to an interesting presentation. Albert, the floor is yours.
Thank you, Johan. So good afternoon, everybody. So first of all, I would like to thank Enerchange and FIG Geoenergy to give me the opportunity to report about what have been done in northern Alsace, in the Upper Valley, and mainly we'll focus to speak about some issue we have with induced seismicity and how we manage them today and how we discuss with local population, because if we have no social acceptability, we have no project. So in order to present this topic today, our main outline, I will say who we are in one slide to know who is speaking. I will say some word about why we are in the Upper Valley, what was the historic development in northern Alsace, mainly in terms of induced seismicity, and what happened during some geothermal operation today, because we, as mentioned, Joren, we are exploiting two plants. Some future development, because we exploit some brines and they are rich in lithium. And then I will focus at the end about, I would say, acceptability issue and what could be improved, how we can manage them in this area. And as you know, we are working in the Upper Valley, which is at the border between Switzerland, Germany, and France. And we exploit two plants, one in Soultz-sous-Forêts, which is well known because it was a scientific, I would say, laboratory for decades. And we built a second geothermal plant in Rittershofen, roughly 10 kilometers away from Soultz, which is today producing heat for an industrial partner, a biorefinery, which is located around the Rhine River in Mannheim. But we have, I would say, only some words, but we have also a third with a site, which is in Ilkirch, south of Strasbourg, where we drill one wells, but we were obliged to stop this project due to the mining authority. They suspend our agreement for drilling the second well because of some earthquake felt in the Strasbourg area. But I will come back on that. So first, who we are. I will not drill all these slides, but who we are. We are our mother company, ÉS Geothermie Strasbourg, is developing renewable energy, and our group, we have a biomass plant, we have geothermal plant as mentioned, also mini hydraulics. So we are able to produce electric power plus heat and somewhere save CO2. But so we are deeply involved in energy transition, and if I focus more on the geothermal aspect and lithium aspect, so it's our main work about that. Our mother company is shareholder of the Soultz and the Rittershofen plants. Our mother company is also the owner or co-owner of several licenses for geothermals, as well as two geothermal concession, and also we have two exploration licenses for lithium. And finally, we have a team, our ÉS Geothermie team, where it's a daughter company of ÉS, and we are kind of competence center because scientifically and technically, my colleagues and myself, we are operating plants. So we are working also on the geothermal lithium, but so more than also exploitation, we are also deeply involved in some research projects, and I will say some words about that also today. So why we're in the Upper Valley? So it's well known, it's a rift zone, and here a map geological map of the Pine Valley, and there are several geothermal plants, so Soultz-sous-Forêts and Rittershofen, but also some on the German side in the Palatina, Landau in Salm, and also in Bruxelles in the Bad-Württemberg. It's an area with a very high geothermal ground. There is at large scale well-known geothermal anomaly, and it's one of the areas which is the geothermal is 3 times higher, for instance, than in the Paris Basin. So regionally, it's quite interesting in terms of temperature. We start to work in this area a long time ago, more than 30 years ago, by doing this French-German project at Soultz. We started with dry rock, but slightly we moved to EGS. I will come back to that also. And we drill deep wells at 5 kilometers in Soultz, where we learn a lot. And what we learn that by drilling, we find natural water. So brines, very salty water. And those water was, we also understood that those waters, their permeability is mainly at the interface between the sediment. It's a kind of cross-section of the valley, of the sediment and the granite. And in our case, most of our well, we find more water, I would say, at the top basement, which is a highly fractured zone, and a bit less in the Triassic layer like Buzenstein or Muschelkalk. But mainly our reservoir, which are here, and in fracture zone in this part of the graben. So in terms of concept, we moved with we changed by learning. Each time we drill, we learn many things. And at the beginning, we think in terms of dry rock, meaning that it's deep, it's hot. At great depths, you have hard rocks, and those hard rocks you have to frac them and to create artificially a heat exchanger and work in a closed system. So this, at least this concept in the field where we are, doesn't work or didn't work. But what we find brines, water, natural brines, and we were obliged to develop some techniques for connecting the wells, I would say fractured reservoir, and we were obliged to make thermal, chemical, or hydraulic stimulation. And then we had induced seismicity related. And today, our main thinking is we are more in a hydrothermal system. We think that we have those faults, which are normal faults or shear faults, but in those faults, there are some natural fluid circulation, convection, which show very low thermal gradient in this part of the well, and also some specific feature like argillic hydrothermal alteration with some secondary minerals like illite, it's a kind of muscovite, or also secondary quartz and many things, and also high fracture density in these zones. So we move from dry rock to EGS and to hydrothermal system. And then it was mentioned by John, our I would say daily business today is to operate 2 plants. And those 2 plants, one is producing electricity, but it was a lab. And then we try to, from a scientific to a more industrial project. So this site is extract, and we are producing electricity a bit less than 2 megawatt electric. And you can see the temperature of injection and production. And one thing which is interesting is in 2021, we have, based on the research project, we were able to produce some lithium carbonate from the brine. And then we demonstrate the proof of concept that it's possible to extract, I would say, lithium carbonate of battery grades from brines, from the brine graben. And I think it was the first time it was done in this area. So the second plant we are operating is Rittershofen, which is brand new. And if you compare the well of the depths, in Rittershofen, we drill at only roughly 2.5 kilometers deep, compared to 5 kilometers in Soultz. We learned that the top basement is much more fractured than the deep basement. So we are producing roughly at flow rate higher than 80 liters per second in Rittershofen, and we are producing heat for a biorefinery, which represents roughly 24 megawatt thermal and a huge amount of heat. And last year, because if you accumulate the production from 2016 when we start production, we produce more than 1 terawatt of heat from the beginning of the production. So it was also a huge amount of heat which can be produced for biorefinery. So we have a long experience, which is shared also by many other people in Europe. And you can see also how much was invested for doing this kind of research and now more industrial project. But Soultz, because the topic of today is more related to acceptability and in fact induced seismicity, I prepare a kind of overview what happened in the past. So we start at Soultz, and first it was R&D, and we moved slowly to industry. And during that period, we drilled wells, we stimulated the well, we did circulation, and we built some binary plant for producing electricity. But what happened in 2003, during a stimulation of one well, we have some induced seismicity, and some events were felt by the local population. So there is more or less no damage on the houses, but people felt, and it was a problem with local people. So we decided to start to continue with Soultz and then to extract the site. And from 2016, we built a new plant. From 2016, we extract and we are doing the maintenance of the plant. And I can say we have no felt seismicity from this date. In Rittershofen, we start in 2011, and we did the same. We explore the site, we drill 2 wells, we stimulate the first wells, and now we are exploiting the wells. And again, we were able to do this project without any stimulation or felt induced seismicity, and I will show you some results later. And the third project, which is in Ilkirch, we start to drill in Ilkirch, south of Strasbourg, first well. We did first exploration, 2D seismic, for instance, but only 1 well was drilled and stimulated. But because of some earthquake felt and generated by another operator in Vandenheim, during that period, 2019-2021, the local prefecture stopped Ilkirch, and today still stopped. So we cannot do any project today in the Strasbourg area. Is the reason why we will continue to work in the northern part of Alsace, and I will show you mainly results today, or some results which happen in the northern part of Alsace, but not in Strasbourg. So for us, at least, we are able to operate 2 plants. One of the messages of today, I will say probably several times, we are able to operate geothermal plants in granite reservoir with no felt induced seismicity, which is very important for our company. So you see here, I come back to also a bit of history. I had more information. So first, on the right, you can see some stories in French, which is French newspaper from 2003, when the event was felt at the time 2.9 in terms of magnitude. So you see the people were worried. So we need to improve that. So in Soultz, we have this earthquake 2.9, but with no damage. Some years later, there is also another project in Switzerland with magnitude 3.4, but with damage, and also high pressure was used for stimulation. And at that time in France, there is no real regulation or good practice to limitation of injection. But when we did Rittershofen, we were very cautious, and hopefully we have no event. And when we start to do Ilkirch in 2015, we have this French regulation mentioned by the French Mining Authority, which is we cannot go over than 100 bars of wellhead pressure, and we apply this number to Ilkirch project. But another competitor, which were operating at the same time in Vandenheim with the same regulation, generate a series of about 10 felt events. There are some paper on that, and with some damage in the houses, and then it generates the full stop of Ilkirch, and also a big, I would say, damage in terms of acceptability in the mind of people in the Strasbourg area. So one message we are doing and we recommend is to follow the rules defined by the mining authority in terms of monitoring. I will say some word about that, reporting and operation. And in our case, we always follow the rule which have been given, and we had no issue. So how, first, before to show some data, how we are measuring induced seismicity. So my colleagues, so we are deploying several networks or potential networks. So first we have to deploy a real station, as here, says more about the number. We have to deploy sometimes some temporary station. For instance, if you are doing some specific operation, we did some with KIT, for instance, some during stimulation. And for other kind of R&D, also we deploy some seismometer. And also we oblige the mining authority ask us also to measure continuously GPS. And so we have on site a GPS antenna. So I will give you more information about how we work. So we have, for each site, we need to have 4 permanent stations. Also 1 multi-sensor station, which is measuring broadband, slow deformation, and also 1 GPS, as you see it. And you have to be aware that the multi-sensors data plus the GPS data, we need to send them to Strasbourg University. There is a dedicated, we'd say, part of the Strasbourg University which work on that. And those data from multi-sensor plus GPS, they are publicly accessible. Then in our part, what we have to do as operator, we have to do continuous seismic activity, continuous seismic acquisition in real time. We have software and we can also make automatic processing of the data, detect them, locate them, archive them in real time. And in case of, I would say, some threshold, I will come back on that, we receive some alert by email, SMS, or other system. And internally, we have an expert or several experts able also to relocate events automatically to check if it's a real event or fake, it happens. And also we have to report regularly to the mining authority. So we have to do monthly report, yearly report, and we are also doing some presentation also about what we are doing on our site in terms of induced seismicity and other things. And generally, and you will see that on the next slide, we express those data sets not in terms of magnitude, but in terms of peak ground velocity. It's a vibration, which is expressed in millimeter per second. So this is our, I would say, own traffic line system for us, and we have a scale with 4 main thresholds. So you have here the peak ground velocity in millimeter per second, and you can see here the correspondence in terms of magnitudes. So for instance, what is green, it means that we are below 0.5 millimeter per second. So it's a normal operation. If we observe a value between 0.5 and 1 millimeter per second on 2 stations, we have to ask a seismologist to have a continuous monitoring of the data and to check carefully what is happening. If we are in this rate of 1 to 1.5 minutes per second, we have to reduce the injection flow rate. That means that we have to reduce the downhole pump speed because we have a downhole speed, which is pumping the fluid. And if we are over this value, we have to do a progressive stop of the plant and to stop everything. So you see those thresholds which are here. And we think that internally people can felt an event around this value, which is the red threshold. So this scale is given by the mining authority, and we have strictly to follow it when we are doing continuous monitoring, drilling, exploitation, or even stimulation. So this is the result we have in our 2 sites, and you can see a map here of local maps. So this is the Rittershofen site. What you see here is the well trajectory, the projection of the well, because they are not vertical. So you can see their projection on a horizontal map. So you can see that for Rittershofen plus for Soultz, most of the induced seismic activity, which is green and respectively blue, is close to the reinjection well. This is the first observation. Second observation, we have much more event in Rittershofen than in Soultz. So it's a cumulative number of events we have from the beginning of exploitation. That means from 2016, we have roughly, let's say, 350 events in Soultz and around 5,000 in Rittershofen. And the last things which is on this slide is also there are some black dots, which correspond to also natural earthquake, which also happened in this area because the Upper Rhine Valley is also a quite active area in terms of seismotectonic. So we measure induced event in Soultz and Rittershofen, but we're measuring also natural events. So one thing which is interesting, I already mentioned, much more event. So every event, all the events, are on the injection part, which is quite interesting for both sides. And how we could explain that? We could explain that because we are injecting a cold water, because we are pumping out water, we are taking the energy and we are re-injecting at low temperature. So low temperature for us is roughly 80 degrees C. And then we have a kind of thermal impact on the reservoir. So we can think that a part of the induced seismicity is related to also this thermal impact. The flow rate in Rittershofen is more than 2 times higher than in Soultz, and it could also explain why we have more, I would say, hydraulic impact in Rittershofen than at Soultz. And also you can see, so we can see also some many earthquakes. Sometimes they are aligned, so we suppose that we could have some structure in this area, but at gut depths, which could be also active. And one thing which shows you have to be aware, if we add no sensor, this map will be fully blind. There will be no point because we have many sensors, we are able to detect and measure them, but they are very low magnitude, and we never observe, I would say, events which has also PGV higher than 0.5 on 2 stations. One thing also which are doing our colleagues from exploitation and my colleague Vincent Morel from seismology and Clément also are checking that. For instance, here you have a time slot here, so several hours, and here you have a magnitude, or you have I would say a flow rate, and here you see you have a kind of we have our own, I would say, empirical traffic light system. Here the PGV are quite low, but even they are quite low, we have a kind of cluster seismic event. As we have some alerts, we decide to reduce the flow rate about 10%. So you see, we are going from 300 to 2070 cubic meter per hour. And during a couple of hours, about 6 hours, we reduce the flow rate. And then after, the induced seismic activity disappear fully. And then we ask people from the site to come back to nominal operational data set, and then we restart. So we are not waiting to have, I would say, an issue we are doing ourselves some self-prediction, I would say, of the flow rate and then of the microseismic activity. And then we have no issue with this activity related to our exploitation. We are working in exploitation, but also we know that we need to improve things. We are also doing R&D, and in seismic activity, we have a new project we start during summer, so I have no result to show you, but you see the name of our partner, BRGM for France, and KIT, and also CEMEX from Germany. And this project the idea is to use machine learning, artificial intelligence and induce seismicity. Yes. We will reinterpret probably, I would say, older stimulation operation to try to see we can have a message in that, and we can maybe forecast some things. And we will have a look also on some parts of exploration, as I showed previously, to see if we can find some, I would say, rules of ID, not empirical, but based on this kind of approach. So this project is starting, and it will be more concentrated about Rittershofen. We are working in the induced activity, which also generates some fear and so acceptability issue in the population. But also, we start to work in the lithium, which also generates some fear. And so I would say 2 words about lithiums. So as you know, we are exploiting brines. And if you look here in this table, we have several sites in the Alpine Valley from Germany and France. And all of them, it's well known, they have a quite significant quantity of dissolved lithium, around, I would say, 200 grams per lithium. And then if you see in time here, it's Soultz-sous-Forêts and Rittershofen value, the value is quite high and stable. So in space and in time, it means we have a resource in the Alpine Valley. And as you know, there are several operators which are looking also for lithium extraction from the brine on the French and the German side in the valley. We conduct a research project some years ago, and I mentioned that during the introduction. And what we see, we were able from this research project to have a kind of plugging on the plants on Soultz and Rittershofen and we were able to extract lithium, and which is here, and then we produce our first kilograms of lithium carbonates from geothermals. And we did some calculation at that time, broad calculation, saying that maybe we could extract till 2,000 tons of lithium carbonates in Rittershofen per year, if we are able to assume some good direct lithium extraction processes. And the last word about lithium, we start in spring partnership between ÉS Group and Eramet when we did this research project. And our target, in fact, just a few words, but our target is to produce lithium carbonate, roughly 10,000 tons of lithium carbonate per year. That would be from 2030. So it's our target. So to go that, and we are working now on that with Eramet to start to think more industrially this kind of approach and to reach those goals. So I mentioned induced seismicity and mentioned the lithium extraction, and then it could generate some fear in the population. So in 2012, we did the first social, I would say, study in the Alpine Valley, which has been published in 2013 in Pisa during the EGC. And here, what we did, in fact, we work with social scientists, and we select some criteria. Sorry, it's only in French, but induced seismicity, noise, pollution, natural radioactivity. So we ask people, we did a questionnaire, and we have people close to Soultz, so the Soultz people plus the Kutschenhausen people, and with the I would say the help of the mayor of both civil houses, we did this survey. And what are the main results? The main result, the main fear was mainly about the noise. On this bar chart, the noise is the highest, I would say, level. And then second was induced seismicity, and you see the date, it was roughly 10 years after the felt earthquake of 2003. And some people, and the oldest in yellow, told us that they remember that they felt the earthquake. And if you look the other potential issue, pollution, air pollution, water pollution, and so on, radioactivity, and so more or less very low, I would say, fear about those kind of potential nuisance. So at the end, we got rather good feedback from the local population, except we need to be care about noise and induced seismicity. There are many others, I would say, social studies that have been done by various people in the Alpine Valley. I will not report on them, but and I'm close to the end. And what we are doing today, we have this problem with the earthquake in Strasbourg, which for us damaging a lot. It was also a kind of a nightmare and damaging a lot acceptability about geothermals in the Alpine Valley, not only in France, but also for our colleagues in Germany, in Switzerland, and maybe in other European countries. So we had also the COVID effect, but we wait. I would say that we come back a more quiet, I would say, period, and we restart to open the plant. And as Rittershofen is a brand new plant, we add some, I would say, educational panels, which are just below my colleagues here. So we have a series of explanation for people. And then what we are doing site visit. So we open the plant, and the idea is to better explain subsurface, to better explain how works the plant, and to show also, to show experts, to show people, and to show to also people the plant directly. And then it was quite interesting. And if I compare some numbers, so we reopened the plant last year in September. So we had more than 1,000 visitors, and in roughly 70 visits. And here you have also a kind of a chart about who is coming. And mainly it's local citizens, or citizens are coming. It's the main population which is visit us. But we have also people from academics, a lot of high school from France, Germany, and many countries, in Switzerland. And also we have also people from industry are coming to see our worker plant. And then we have also people from, I would say, journalists, people from government, and also politician, local politician or politician in general also coming. So we have a real, I would say, a good success to those visits, and we will reopen the plant at the end of September also for a new series of visits in Rittershofen. If you want to know more about what we are doing, we also, I mentioned, we are also in research project. We publish paper, for instance, about induced seismicity. There is a nice paper did by Vincent and collaborator, which is accessible for free in geothermal energy. And we did also, Clément Beaujard also did a nice paper about simulation in Rittershofen. We did also some book chapter, a recent book chapter, and one will be online soon about EGS. But to conclude my presentation and my different message, which was about geothermal energy, we need to better explain to people and especially to non-technical stakeholders, because there is not only one geothermal energy, there are several kinds of geothermal energy. There are domestic geothermal energy, for instance, shallow heat pump. Deep geothermal energy is not the same, I would say, benefits or drawbacks. So it's really important to, I would say, educate, to be pedagogic and to explain better to the people. It's also not obvious to explain geology to people. So we need also maybe some tools to better represent the underground. What is a fault? What is a layer? Sometimes people ask us, you will do a big hole if you extract the lithium, but the lithium is dissolved in the water, is not extracting the lithium from the rocks, things like that. We have to explain also the technology, how work a Donald pump, how work heat exchanger, and so on. And then we have to explain the risk, but also the benefit. We already mentioned that we have a low carbon emission project. We save CO2. I didn't insist on that, but it's quite important also. And I would say our main target as an operator is to reduce as much as possible and to minimize induced seismicity. And as I show you today, that we try to do our best to avoid to have fault event related to exploitation. But we observe also we need to give real confidence to the people. We need trust from the broader public, because and for that you need to have experts. You need to train also young people, engineers, scientists. We need to do R&D, and also we need harmonized rules. As I show you PGV, we think it's a good tool because it's structural measurement, and also to have good practices and to follow those practices. What we try to do permanently. So at the end also, what kind of benefits we can bring to the people? Because sometimes they say, okay, you're doing a plant, it works, there is no fault event, but what our own benefits? So we have to show we can do many things for them. We have to be clever to make, for instance, not only electricity and heat for industry, but we can also make greenhouse. We can provide heat for local district heating. We can maybe also install some electric charging station for electrical vehicle and things like that. So in the future, we have to be more clever, and we have to root locally the project. And so it's very important to associate people when we project. So we are not only doing technical and scientific good things, but we have also to think socially, which is a message. And at the end, we try to be also as much as transparent as we can by doing this kind of public visit, but also publishing many things on the internet, and also to have a kind of two-way communication. It's not only industry which explain to people. We need also to be able to listen what are doing non-public stakeholder, and they ask many things in terms of question, and we have to be also aware about their concern, and we are on the way on that, but it's a long way to do. So I would like before to thank you for your attention. I would also to thank my colleagues. You have their name on the screen, so they helped me to do also this kind of project and this kind of results. So most of my colleagues are there, and I put here also, if you speak or read French, there is on YouTube. There is also, I can promote on YouTube. If you type Central Geothermic France, you will find a brand new, I would say, video about Rittershofen, and Eleonore Dalmé is a guide of that. And I think it's a good way if you want to visit the site from your office. So thank you very much for your attention, and thank you again for giving the opportunity to report about what we're doing in Northern Alsace.
Thank you very much, Albert, for this very nice presentation about Soultz and Rittershofen and your other efforts you're doing. We already have some questions, which I will pass to you. The first one is about hot dry rock. You said hot dry rock didn't work. Do you think that multi-stage fracking might work?
So I would say hot dry rock in the Alpine Valley is probably not the right place, because I know some projects in Forge, for instance, in US. It's a research project led by DOE and many scientists there. So I know they have good results, and I saw a presentation done also by Mark McClure some weeks ago. So Forge is working, but we are not in the same geological condition. And so I would say hot dry rock could work, but mainly not in area where you have people, and probably in area where you have a rock which have not been fractured. And it's not the case of the Rift Valley we have in Europe. The fracture density in the granite is about 3.5 fracture density per meter. So it's a very highly fractured rocks. So natural feature, natural permeability is dominating. So if you want to do a dry rock, you need to find, I would say, massive rock which are not fractured naturally. So maybe you can have success, but in our case, even I published many papers when I was young about hot dry rock. There is water, and we think we have geothermal in the Alpine Valley, and all the other sites also are pumping water from fracture zone. So hot dry rock, yes, but maybe not in our valley.
Do you think that multi-stage fracking might work in the upper Rhine-Graben?
Okay, so multi-stage fracking, I have no experience, but maybe it could work. It could work, but in our case, for instance, in Rittershofen, we were obliged to stimulate the first well, and because his productivity or injectivity was quite low, so we did combined stimulation, thermal, chemical plus hydraulic, and we improved the injectivity by a factor of 5. But now the well is too good. We are obliged to put in the injection well a kind of restriction because the well is too good in terms of injectivity. So we think that in our future development, and we want to do new projects in the valley, in our mind, we think we can do project without any stimulation because natural permeability is there. The challenge is to be able to locate the natural, I would say, permeability in the granite or in the sandstone, and to avoid stimulation. But multi-stage could work, but in our case, is not in our mind to use it for future projects.
Okay, there are furthermore questions. How is success in managing public perception measured within ES efforts? What are your thresholds for assessing positive and negative perception?
So you mean how I can relate, I would say, new seismicity and the perception of people? Huh? It's difficult because, you know, in the past, we have a very good, I would say, acceptability of the people. And it was not a real topic when I started to work at Soultz. Only scientific, I would say, question about the underground was on the table. But social science and also now people, they would like to be aware, they would like to be informed, they would be to be more involved. But to measure social perception, there are some tools. There are some papers done by the team of social scientists from Strasbourg, from Philippe Chavot. So I think there are some social science tools measuring, I would say, how people felt, I would say, a technology, but I'm not able to give a scale, or I'm not able to for us, the only way we measure it is to open the site, to explain. And some people came and they changed their mind, and some people they came and they don't change their mind. But at least we explain, and they have an idea by themselves, and they can see by themselves. So the proof is the best way to show and to convince people that we are doing projects to avoid or to minimize at least many risks.
Okay, thanks. There is another question regarding this topic. How do you deal with citizen groups that are not interested in any truthful exchange and only request the information to find approaches for disinformation and to scatter doubts?
So I understand the beginning, how we deal with opponent somewhere. So effectively, there are some new associations. So I know they have a Facebook page, but I haven't. I would say we are doing the same that with people. We open the site to everybody. I know they came outside. Well, last year we have 250 visitors. They came, but they were the only people who did not register before because they think that they are not registered. to come, and we explain them. But it's I have to admit that the dialogue is difficult, because it's difficult to speak to people who would say don't want to listen. But we speak to, I would say, several levels, and to non-technical stakeholders. We speak to local politicians. For instance, we hosted many mayors plus their team this year. Several cities they came, so roughly 20 people each time, representing some village. And we explained for more 3 hours. And for instance, the presentation I did for you, we present that regularly to everybody who is coming on site. So we are showing what we are doing, and we are explaining, and sometimes people are unhappy, but we are showing what we are doing. So, but I admit that communication with opponent is difficult, but it's our task to try to show them and to show that we are doing things fairly and by respecting the rules and by respecting also Mother Nature.
Okay, thanks. Here is another question regarding public acceptance. Which instruments, tools did you start to get acceptance in public and to reach the citizens?
Which tools you mean? Yes.
Yeah.
So the first tools we use, I mentioned it, it's site visit, but maybe some tools, I already had some discussion with some people about that. For instance, I mentioned that it's difficult for people to represent the underground. When you say we are pumping water in a fault means even the name fault, they are afraid about faults. But I say there are thousands of faults in the Pine Valley. If you are looking, say we did a 3D seismic survey, there are faults everywhere. So it's a normal geological feature. So I think one thing should be to develop maybe some tools, some on some computer or tablet, and you can explain or show to the people the fault. Maybe you can show some 3D models also to explain, and they can be more maybe if you are able to educate a bit by a tool accessible, could be a way also to better explain.
What do you think about huff and puff could work in such geological settings? A huff and puff is explained cycles of injection and production, inflating and deflating created fractures.
Yes, I don't know this. I think I don't know this technology. That means that we work probably in only one well, or maybe I didn't understand exactly. I don't know this concept, I think, but sorry, I'm not able maybe to answer.
Okay, perhaps it might be explained, and we return to it later. What percent of the year is the plant down, or do you maintain injectivity and production all year?
So the plant is generally we are doing 2 periods of maintenance, short term, one in spring and one in autumn. Why? It's because our end user, the customer buying the heat, also is doing maintenance. So generally it's in March or April. We stop for one week or 10 days, and we are doing the same in September or October, roughly 1 week or 10 days. So that means that the plant is operating roughly, I think in average, it's higher than 90% of the year. So we are just stopping the plant for some maintenance and also for doing some logs. For instance, sometimes we have to do some logs for administration every 3 years in injection and every 6 years in production. We have to make some integrity logs, but the plant is working more than 90% of the year. I think in average is 93%. So and during the year, the injectivity and productivity, so the flow rate is controlled by the end user, and the maximum flow rate is roughly around 83 or 85 liters per second.
Okay, thank you very much. The next question is, why is there more seismic events in Rittershofen than in Soultz?
So maybe I was not clear. So there is more events in Rittershofen than in Soultz because we think that the flow rate is higher in Rittershofen than in Soultz. The flow rate is roughly 80 liters per second in Rittershofen for 30 liters per second in Soultz. Plus, in Soultz, we have 2 reinjection wells. So we can divert the flow in 2 wells. So somewhere we can share, I would say, the pressure in 2 wells or the flow in 2 wells. So Soultz, less flow rate, 2 injection wells. Rittershofen, 1 flow rate, well, 1 reinjection well, and higher flow rate, maybe more than 2.5 what we have in Soultz. So it could explain why we have this more, I would say, induced seismicity in Rittershofen.
Okay, it's not related to the rocks in the subsurface.
No, because the rock is the same. The rock is the same. We have the same kind of reservoir. We have the same kind of minerals in the fracture. So this is not related to, I would say, at least the geology.
I want to return to the question before. We have now an explanation about it. The half and half operations work with one well only, indeed. Cold water is ejected and deflating artificial fractures with controlled shape by avoiding going beyond fracture propagation pressure during the fracking. Water is left in fractures for about 10 hours to heat, and then the well is reopened to produce hot water while deflating. So
it's a single well. Mm-hmm. So yes, the question
to a single well. But you could imagine that something like this could work in the Upper Rhine.
I don't know. I knew some project like that managed by the BRGM in Hanover, also to have only one well. I saw some.
Yes, but there was no half and half operation, I think.
Yes. So frankly, for me difficult to answer if this kind of technique could work. In our mind, as we know, we have water. We think we need a doublet. We need injection well, we need a production well, and we need to take the energy and to re-inject the water. And in France, we have to re-inject in the same reservoir, so we need also production plus re-injection. So single well, I need to think about, but I'm afraid that I'm not able to answer properly and to give a nice idea to people who ask the question.
Okay, thanks. Do you have a 3D geological model, and do you share it with the public?
So we have a 3D geological model. We have even several 3D, and sometimes when we have presentations, so we can show the 3D model on the screen on some slide. But I would say, if you are not familiar with 3D model, people are lost. Is the reason why I mentioned it could be nice to have maybe on some tablets some interactive tool to people can play with the model. There are some software with some where you can have a kind of casque or helmet and maybe play with the model. But it's difficult to explain geology, complex geology with simple tool, and especially 3D. Generally, we show 2D models or 2D cross-section to the people because they could understand better than a 3D, which is quite complex. But we share some slide about the 3D model with the public. Yes, it's not a problem, and we publish it also in Beaujard et al. 2017 in Geothermics.
Okay, thanks. Here is a question now about your operating staff. What's the size of the staff running the plant? How many people work on a shift, for example?
So in fact, in Rittershofen, for instance, during the RIT, there are 1 or 2 guys only, and they start at 8 and they finish at 5. Nobody is working the night, and nobody is working during the weekend. And geothermal is working more or less all the time. But we have a system with many, we have an automatic system which is connected also with a biorefinery of rocket, and we have many sensors. So during the night and during the weekend, we have one of our colleagues is at home, but he has a computer, he has also a special phone, and in case of issue, he receives, like for seismology, he receives some message, phone call, email, SMS, and he can be connected remotely. Sometimes he can manage to a small issue remotely from his home, and that's it. And sometimes you have to go on site and to, for instance, restart the plant because something happened. But normally there are more or less nobody on site. It works alone. And then it's quite a modern plant, I would say. And also we benefit for that also from Rocket, which is the company who built the biorefinery, because they have a big factory and they used to work with automatic system for controlling days and night industrial and infrastructure.
Okay, thanks. Here is another comment to the question. Would be interesting to know if the local population can be engaged by creating jobs.
So, for instance, some of our colleagues, for instance, live in this area. For instance, I was living at Soultz for 7 years. So we have colleagues living at Soultz as well. So we also engage locally. And for instance, also last June, 2 of my colleagues also, they did a visit to the school of Rittershofen. So the pupils came with their mistress and came, and then we present the plant, but we adapt, I would say, the presentation to their level, and then people, they enjoy also to see what we can do locally. So it's important for us also to present what we're doing, not only to, I would say, the mayor or to some VIP people, but also to citizens and also to kids, because tomorrow kids will be also, I would say, citizen. So locally, we also, in terms of job, most of our technical team is living in the village around the plant.
Okay, thanks. Merci, Albert, for the update. According to you, is it better to explain in the most simple words, like for kids, or should we give people more credit and use some technical words they can learn and get used to?
It's a good question, because sometimes it's clear that we, as we are scientists or engineers, we have our own, I would say, languages, and sometimes we use some words we are not aware that people have no clue. But if we use also too simple words, and I remember in the past some colleagues were saying geothermal energy is easy, you drill and you pump water, we inject. Nobody was speaking about faults, about induced seismicity. I think we have to put on the table everything. It's not simple. We need brain, we need experts, and also the message I give to people coming on site: if you have a student, there is maybe a future job for you there, if you're interested. But it's clear we have to explain in more simple words sometimes to people. So we have to do this effort. But unfortunately, we have a bias, and sometimes we use words which are not understandable by people. I admit it's a good question, yes.
Here is the last question. What are the next steps for the Ilkirch project, and when could it be restarted?
So for Ilkirch, still shut down, we don't know. And as the acceptability in the Strasbourg area is very low, I think my management is not pushing that. So we are waiting that, I would say, better days for new project or new drill in Ilkirch. But in the northern part of Alsace, I didn't mention, we would like to plan, and we ask to drill new sites, probably one in Soultz, one in Rittershofen, because we have concession, and probably one in the area of Weissenburg. So we have, I would say, we ask French administration. We did some dossier for that, which are still in instruction. But we prefer to develop the northern part because we have expertise, we have staff, we have already plant in operation. And for Ilkirch, I think it will be longer, maybe not now, but we first will go to the north, and maybe if we demonstrate that the north is operating well, we could convince people from urban area of Strasbourg to accept to do a new project. But today we make a priority and a hierarchy to work in the north of Alsace.
Okay, then thank you very much to you, Albert. Thank you very much to the audience and many questions you sent to us. I wish you everyone a very nice weekend and hope to hear you soon in 2 weeks. Bye-bye.